talking about biserial, bivariate, semi-partial, and partial correlations. I'm going to start with biserial. Don't know if I'm pronouncing that right, but I'm just going to go with it. So biserial correlation measures the relationship between quantitative and binary variables. The biserial correlation is a correlation between one or more quantitative variables to one or more binary variables. When I hear the word binary, I think of dichotomous, which is a variable that can only be one thing or another. So binary variables can only take two variables: male, female, true, false, yes or no, things like that. Quantitative variables are measured on a numerical scale, as you probably already know. It's just easier for me to think of quantitative as continuous variables. Continuous is any value between its minimum and maximum value, like temperature, test scores, things like that. The biserial correlation coefficients vary between -1 to 1. Corresponds to no association. The means of the quantitative variable for the two categories of the binary variable are identical. You would use a biserial correlation when you want to measure the strength and direction of the association that exists between a continuous and a dichotomous variable. A bivariate correlation is simple and finds the relationship between two sets of values. It usually involves variables x and y, so the two variables could be an average SAT score, an age of college students, or you can find their weights and heights, or calorie intake and their weight, things like that. They can be dependent on each other, like ice cream sales compared to the temperature of the day, or the traffic accidents along with the weather of the day. A bivariate correlation can be helpful to predict any natural event that might occur. So with the weather, you might see more accidents on bad weather days, and that can predict more accidents in the future when the weather's bad, things like that. It's easiest to make it into a scatter plot so you can see, like, okay, there were more ice cream sales when it was hotter than it was when it's colder. It's just easier to see on a scatter plot. Biserial and bivariate both start with bi, which means two. Biserial is comparing binary and continuous variables, while bivariate is finding the relationship between two sets of values that are both continuous. This may be weird, but I think of biserial and I take the word serial and I think of serial killer, because I watch so many murder mysteries and documentaries, and that's just how my brain works. So I think of it like, are you a serial killer? Yes or no, which is that the dichotomous variable or the binary variable, and then the continuous variable is how many people did they kill, and that's just how I remember it. It separates it in my mind, and I can sort it out like that. I know it's weird and it's dark, but my brain is just messed up. When you want to know the influence of one independent variable on a dependent variable, but one or more other independent variables pose an alternative explanation, we use partial correlation. When we want to hold some third variable constant while examining the relations between x and y is when we use partial correlation. The basic idea between partial and semi-partial correlation is to examine the correlations among residuals or errors of prediction. So in partial correlations, we find the correlations between x and y holding z constant for both x and y. Sometimes we want to hold z constant for just x or just y. When we want to do that, that would be a semi-partial correlation. A partial correlation is computed between two residuals. A semi-partial correlation is computed between one residual and another raw variable. An example of partial correlations is when you might want to see if there's a correlation between the amount of food eaten and blood pressure while controlling for weight. So all variables are continuous. An example of semi-partial correlations is when you find the relationship between test scores to GPA. So bear with me while I try to explain this. So if somebody argues that an advanced achievement in math score will predict GPA and the SAT scores will have no value to it, then you would want the achievement test to be partial from the SAT test but not from the GPA. So the achievement test is constant for the SAT and see whether the SAT can still predict the GPA. Hope I explained that right. So with partial and semi-partial correlations, they are testing 3 variables with one being constant. Biserial, partial, and semi-partial have continuous variables, while biserial have a binary and continuous variable. So I hope I explained that well. Makes sense in my brain. So that's what's important. I hope it helped any of you. So yeah, thanks.